Hello guys, you welcome to my channel. Today we are going to be looking at the concluding part of the electricity practical, that is the 2020 NECO exam. Good. This morning I'm going to bring before you the exact question that we are to expect as regard the practical. 90% exact. Yeah, that is, it is 90% certainty that's the question they are going to be asking us. The only thing that might change is going to be the value that I'll be presenting before you. But before we go into that, I would like you to understand the theoretical aspects of this experiment. If you understand the theoretical aspect of the experiment very well, that will assist you and guide you when you are doing the practical, and that will easily make you get your result very fast and swift. And it will also assist you whenever you are plotting your graph or you're getting a certain reading and you're doubting. Okay, remember, whole experiment is to verify a certain theory. Now let's look at this experiment we have. Like you can see on the screen, that is the question that we are going to be expecting in the said exam. But let's look at the board now. We have what? The circuit diagram on the board. Here is a resistance box R, and here is a 2 ohm resistor. If you remember, when we look at how to assemble the apparatus in our last video, as you can find the link in the description below, I made mention and I explained how you can connect how you can connect the circuit, and I show you, instead of having 2 ohms resistor, we are having an unknown resistance. That is a wire that wants to know its resistance. That's to tell you that in some cases we carry out this experiment to know the specified resistance of a certain conductor. That is, we don't know the resistance of the conductor and wants to measure the resistance of the conductor. We can arrange this experiment to determine that. If not, we might want to verify the formula that states that the resistivity, that is the specific resistance of a material to the length of that material, is a constant. That is, if I have that resistivity, that is specific resistance, divided by the length of the conductor, this is going to give us a constant. And this is a theory that we always use in solving a question under meter bridge. Now, this line AB is the length of the conductor that we have on this meter bridge. Hence, the conductor will have a specified resistance, which we call its resistivity. Now, if I really want to show that yes, it is true that resistivity of a material is a constant, that is, for this particular material, its resistivity will remain constant irrespective of the length, irrespective of external resistance that you are bringing before it, it's going to remain constant. And that is what NECO is about to test this year. In some year, they can want to know the value for the unknown resistance. It's possible. And in some years, they might also want to verify what is going to be the inverse of what we have here. That is, what is going to be the result if we have length per ohms instead of ohms per length. What's going to be? So that's about the aims of experiment on that meter bridge. But this particular one is to show that the specific resistance of every material, especially this particular one, is always constant irrespective of of the resistance or the length of the conductor. And that is what we're about looking at here. So if you look at this now, if you look at this is the specified resistance and this is the length of the conductor. If I keep increasing this resistance and I keep increasing the length, whatever I might be doing, it doesn't change. It will always remain constant. Now, this is the experiment given to us. How can we get our readings? That's the second phase of this class. How can we get our readings with this? For us to get our reading, it is something that is very, very simple and achievable. Now, if you look at the question says you are provided with a meter bridge, standard resistor X, galvanometer, jockey, cells, a key, resistance box, and some connecting wires. All those are what we are seeing on the board. That is, if you finish connecting your circuit, this is what you are expected to have. Now the question now says, Roman figure 1, connect the circuit as shown above. We are going to connect the circuit like that with R set to 10 ohms. So that is, the first reading is for when R is 10 ohms. And that's the first thing we want to look. Okay, what then I'll say, having done that, obtain a balance point J. That is, when we vary this jockey as at when R is equals to what? 10 ohms. And this one is a fixed standard resistor, 2 ohms. By the time we set this one to 10 ohms, at what point will the galvanometer read what? 0. That is the balancing point of the galvanometer. Now, if you keep varying it on this what? On this wire, it's going to get to a point where the galvanometer is going to be what? 0. So we are asked to record that as what? As L. So the question now says we should what? Measure and record the value for L. Then we evaluate L inverse and R inverse. So we are asked to repeat the procedure with values of R to be 15, 20, 25, 30, and 35. Now let's obtain the first one. How can we do this without carrying out the experiment? That is the case. I would like you to pay maximum attention. Now if from here to this place is L, like this, the entire length of this wire is 100 centimeter because it's on the meter rule. Now if this is L, this place is going to be 100 minus L. Now, haven't you know this theory that the specific resistance divided by what? Divided by the length is going to give us a constant, irrespective of what the value of the resistance will be. Now, if that should be the case, if I take, this is a specified resistance here, which is what? 10 ohms. And this is what? This is L, which is the length as at that point. And if you look at this, we have 2 ohms divided by 100 minus L. If I cross multiply, I will have that 1000 minus 10L equal 2L. So we have 1000 to equal what? 12L. By taking this one to the other side, so you add this together, you have this. So the L, which is the balancing point, is going to be 1000 divided by 12. So when we take 1000 divided by 12, our result is going to be 83.33 centimeter. So that's the length. Now take the reciprocal of this, that is 1 all over this. When you take 1 all over this, your result is said to be 0.012. And when you take the reciprocal of this, your result is said to be 0.100. So this one is going to be per centimeter, and this one will be per ohms. Are we together? So we've gotten the value for the first what? For the first reading now. Now the second one, we are asked to what? To set R, instead of 10 ohms now, we should set it to what? 15 ohms. Now, if I set it to 15 ohms, I will have 15 divided by L equal what? 2 divided by 100 minus L. If I cross multiply, I will have 1500 minus 15L equal 2L. So 1500 equal what? 17L. L equal what? 1500 divided by 17. And this will in turn give us 88.24. So when R is 15 ohms, we have our L, that is the balancing point, to be 88.24. So L inverse and R inverse is what we have to obtain. Our L inverse is going to be 0.11 and our R inverse is going to be 0.067. So this is still per centimeter, and this is what? Per ohms, and this is what? This is in centimeter. So are we getting that now? So for us not to waste time, let me quickly generalize this formula so that you will be able to know that once you get to example, this is what to do. Now, let's say this is L, this is R. So if I have R divided by L equal what? Rx, that is the value of this X. divided by 100 minus L. If I cross multiply, I will have R into 100 minus L to equal L RX. So if I open this bracket, I have what? 100R minus what? RL equal L RX. So if I collect the like terms, I will have that L into what? R plus RX equal 100 what? 100R. Are we together? So L, which is the balancing point, is going to be 100R divided by R plus RX. So we can be using this formula now to get our values for every what? For every R equal what? Whatever value it might be. So if R is equals to 10, we just slot in 10 here. Then RX is 2 ohms, we just slot in here. Then we'll get our result to be this. So that is how we can just what? Predict our value. So having to use the formula, we get our table like this. So if you apply the formula, our table is going to be this. So you can just try that on your own. So this is what? Serial number. And this is going to be what? Resistance in ohms. This is what? The balancing point in centimeter. This is going to be resistance inverse in ohms inverse. Then this is going to be what? The balancing point inverse in centimeter what? Inverse. So this is going to be 1, 2, 3, 4, 5, 6 because we have to repeat the experiment 6 times. So this is going to be 10.0 because we are given the value from the question, remember. So this is going to be what? 15.0. This is going to be 20.0. This is going to be 25.0. And this is going to be 30.0. And this is 35.0. Like this. Now, what is the corresponding value of L? This is 83.33. And the next one is 88.24. And what's the next one? Okay, I have 90.91. And the next one, I have 92.59. And the next one, I have 93.57. Okay, 93.75 rather. And the next one, I have 94.56. Here are the value I got after I use what? L 100 what? 100R over R plus RX. So I haven't used this formula. We are going to get all this value. So you can try that on your own now in order to ascertain what I'm saying. Now, if I take the inverse of this like I did earlier, I have 0.012. I'll be putting this one in 3 decimal place so that it will be more accurate because I'm using calculator to get it. Sorry, this column is for half. So this is supposed to be 0.012. So whenever you are using calculator to get a value, you put it in 3 decimal place. So that will give more accuracy than leaving it in 2 decimal or in 1 decimal. Thank you. So the next thing now, for this one we have 0.100. So this will become 0.067, and the next one is 0.050, and the next one is 0.040. And the next one is 0.033, and the next one is 0.029. So complete the column like that. And this one now is going to be 0.011, 0.011, 0.011, 0.011, 0.011. So for all like that. And this is the exact table that we are expecting. Are we there now? So this is the table we are expecting now to have. And if this is our reading, then we can plot our graph. If you look at the question very well, you see that there's nothing like what? Slope. Yes, there's nothing like slope because what we want to show is that what? Either you increase, if you look at the question now, the question says we should plot the graph of what? L inverse against what? Against R inverse. Now let's quickly talk about this. Why we are not going to have a slope, or why our slope is going to be 0. If I plot the graph of L inverse and the graph of R inverse for this particular reading, I'm going to have what? A straight line graph like this. So you can see I have what? A straight horizontal line like this. Okay, let me draw that so that you see it clearly. So this is what I'm going to have. Because what? We know that if I take the delta L inverse and delta R inverse, which is the slope, you will see that my result is going to be R over what? Over L, which we call to be what? A constant. So do we get that now? So this line is not increasing, neither what? Decreasing. It's going to remain what? The same. And that is what they really want to test according to what? According to this practical. Is that taken now? So guys, if you have any question, you can let me know in the what comment section. Then I'm going to tackle them for you all. Kindly prepare for this exam 100% and make sure what you do well and make me proud. Thank you for watching and thank you for always contributing your quota. I really appreciate you guys all. You are the reason why I'm still making videos. So kindly make me proud by excelling in your exams. Now, having said that, if you would like me to make what they cheat on that of triangular or rectangular prism. So we are dealing with rectangular prism in this exam. So if you'd like me to give you cheats on how you can do that very sharp, just like we did here without what any apparatus, you can also do that of rectangular prism also without any apparatus, and you're going to get your accurate result. Absolutely. Just understand what the theory. Once you understand the theory, you can do any experiment. By His grace, on or before Tuesday, we are going to have our mechanism, and that is the pulley that everybody has been waiting for. But mind you, it's not something difficult. We are just to prove the parallelogram law vector in determine. We just want to use that to determine weight of an object, and that's the aim of that experiment. And we shall all catch fun and have fun together. Thank you always. If you are yet to subscribe, kindly do. If you are yet to share within your friends, kindly do. Please like this video, drop a positive comment. As always, we are still a what? Friend. Thank you all.